Electrical currents are paths for which electrical current is able to flow through. A path is complete when the path is closed such that it starts and ends at the same point and is conductive throughout the entire path. The types of circuits include series circuits and parallel circuits. Series circuits are circuits with one path for the current to flow through. On the other hand, parallel circuits branch into two or more paths in which current divides throughout the different branches. The current is the rate at which the number of charged particles flow through or the number of charged particles over time at a given point. This is measured in amps or amperes, and is represented by the letter I. Within a circuit, a battery has two sides, the negative and the positive terminal. The negative terminal has more electrons, making it more negatively charged. On the contrary, the positive terminal will have less electrons, making it less negatively charged. This imbalance will cause electrons to flow from the negative terminal to the positive terminal. Due to an incorrect theory, it is sometimes assumed that it is the positive charges which move within the circuits, which is incorrect. However, since it does not affect the underlying theory apart from the direction of the current, it is still often used. This is called conventional current. As the current flows through the circuit, other particles obstruct the charges. The collision of the charges with the particles causes kinetic energy to turn into heat energy. This obstruction of the current flow is called electrical resistance, which is measured in ohms. As charges are transferred to heat energy as it moves through objects with resistance, charges hold potential energy before its kinetic energy is used. Work has to be done in order to move a charge as it encounters objects with resistance. As it does so, it loses potential energy as it moves along the circuit. The potential difference between these 2 points is then the work needed to be done in order to move the charge between the 2 points. Therefore, charges hold potential energy, and the potential difference is called voltage, denoted by the letter V. Voltage is the potential difference between 2 points and is defined as the energy transferred per charge. The greater the potential difference, the more energy is converted into other forms of energy. The relationship between the resistance, voltage, and current can be expressed with Ohm's law, which states that voltage across the conductor is proportional to the current flowing through it when physical conditions and temperature remain constant. This relation is mathematically written as V equals IR. However, Ohm's law assumes that resistance is constant. When an object follows Ohm's law, it is referred to as ohmic, whereas when an object does not, it is non-ohmic. In a series circuit, the current is constant as there is only one path for the charges to flow through. The circuit's resistance is the sum of all resistances, as the charges have to go through all the components with resistances. Therefore, the proportion of voltage supplied to each component is proportional to the proportion of resistance compared to the total resistance. Voltage in all paths is equal to the voltage supplied by the battery in a parallel circuit. The current is divided throughout the paths according to the Ohm's law, as voltage allows the charges to move but is obstructed by the objects with resistance. The additional paths allows for charges to avoid the paths with less resistance, and therefore resistance in a parallel circuit can be described as this expression seen on screen.